Hello and welcome to Python tutorial. In this lesson, I would like to introduce Python as a programming language, and I would like to talk about some useful commands in the machine learning area. You can use this link to use the main Python tutorial and obtain more information about Python. In Python tutorial, we will introduce the Python introduction. And what is Python? Python is a popular programming language that was created by Guido van Rossum and released in 1991. It is used for web development, software, etc. And the question is, why Python? Python works on different operating systems and platforms such as Windows, Mac, Linux, etc. Also, it has a simple syntax and easy to learn, but not at least. Python has a lot of libraries and packages, especially in the machine learning field. How to start Python? In this course, the codes are executed in Jupyter environment. To do this aim, you should follow this step in order to install the Jupyter Notebook environment. First, you should download and install Anaconda from this website. After installation the Anaconda, you can open the Anaconda Navigator like this figure that you can see here, Anaconda Navigator. And you can see the below picture. Please select the Jupyter Notebook from this navigator, the orange color that you can see here. In addition, you can run Anaconda prompt or PowerShell. Just type Jupyter Notebook and press enter. I can teach you how to use the PowerShell. Then create a new Python for this address and start programming. For more information about Anaconda, please refer to this address. So let's have a look to Python basics. We have to refer to Python indentation. Indentation refers to the space at the beginning of the code line. Python uses indentation to indicate a block of code, and the indentation in Python is very important. In other programming language, the indentation in code is for readability. For example, in this code, if 6 greater than 2, we use the indentation to indicate the block of command. See here, indentation. The first line is a correct indentation. When you put if 6 greater than 2, by some indentation you put print. You can see the print is in red color. And parentheses 6 is greater than 2. Once you run the cell, you can receive 6 is greater than 2. Another example which faces the syntax error is like this. If you don't put indentation, after you put the print here, you can receive the indentation error. You see here, expected and indented block. Means that the print should move a little bit to the right. Another example that we can fix it is like this. If 6 greater than 2, you can put more indent and take another print. So for another syntax error, if you put one if and two print like this, the second print faces to unexpected indent. Python will give you an error if you skip the indentation. Now let's have a look to Python commands. Commands can be used to explain Python code, make the code more readable, prevent execution when testing code. Commands start with A with this symbol, and Python will consider the rest of the line as a comment. For example, you can put this one and you can put your comment for yourself. This is a comment. Print hello world. Another type of comment that you can use it is after your code. The compiler run the printf, then later they face to this symbol. This is the comment. Only the compiler can run your hello world. You should know Python doesn't have a syntax for multi-line comments. You could insert the symbol for each line that you can see in this example. We call multi-line comments. See the example here. One comments, second line comment, and third line comments. Python variables. Variables are containers for storing data value. Python has no command for declaring a variable. A variable has a name, a type, and a value. A variable is created the moment you first assign a value to it, and the type is determined automatically. For example, x equal to 7, y equal to Leo. You can simply print x, variable x can be print, and print y, variable y can be print. You can also use the type command to get the type of variable. For example, get the type of variable using type parentheses, open and close function. When you want to check the type of variable, for example, x, which is equal to 7, only you can put type parentheses x. This line or this code will show you the type of variable, which is integer. Regarding Leo, the variable is y. If you want to see what type of variable y is, you can just put print type y. Then they show you a string. A string variable can be declared either by using single or double quotes. Python has the following data type, and also variable names are case sensitive. Be careful. For example, text type, string. Numeric types, int, float, complex. Sequence type, list, tuple, and range. Mapping type, dict. Set type, set, frozen set. Boolean type, bool. And binary type, byte, byte array, memory view. Text type, also like the previous one, is str. Let's have a look to data structures. There are 4 collection data types in the Python programming language. List is a collection which is ordered and changeable, allows duplicate members. Tuple is a collection which is ordered and unchangeable, allows duplicate members. Set is another data structure, is a collection which is unordered, unchangeable, and unindexed, no duplicate member. Dictionary is a collection which is ordered and changeable, no duplicate member. So let's have a look to list, the first data structure, list. Here we want to use list, and we will give you one example. As I mentioned above, lists are used to store multiple items in a single variable. Lists are created using a square bracket. Square bracket. For example, we created a list. You can put a variable list1, for example, equal to bracket red, blue, green. We created a list with red, blue, and green item. So, since lists are indexed, lists can have item with the same value. After you define a variable list, you can print the list. They show you red, blue, and green. Now let's have a look to duplicate. I told you in the list you can use duplication. Red, blue, green, red, blue, green. Once you print list 2, they show you the duplication. Some useful method that you can use on list. One method is len, parentheses, to determine the number of items. Append, to add an item to the end of the list. Append. Remove, this function removes the specific item. Sort, sort the list. Copy, make a copy from a list. Count, returns the number of elements with a specific value. Extend, add the elements of a list to the end of the current list. Pop, remove the elements at a specific position. Reserve, reserve the order of the list. Clear, remove all elements from the list. Now we are going to talk about tuples. Tuples are used to store multiple items in a single variable. A tuple is a collection which is ordered and unchangeable. Tuples are written with round brackets that you can see in this example. For example, tuple 1 equal to red, blue, and green. If you print tuple 1, you can see red, blue, and green. Tuple 2, red, blue, green, red, blue. When you print tuple 2, you can see exactly the same item. Python has two methods that you can use on tuple: count and index. Count returns the number of items a specified value occurs in a tuple. Index searches the tuple for a specified value and returns the position of where it was found. Now let's have a look to set. Set are used to store multiple items in a single variable. A set is a collection which is unordered, unreachable, or changeable, and unindexed. Sets are written with curly bracket that we use it to create a set in this example. So when you put set 1 equal to red, blue, and green, and when you print set 1, they will give you exactly whatever item or multiple item you have in set. Python has a set of methods that you can use on sets. The method's name is add. Adds an element to the set. Clear removes all the elements from the set. Copy, return a copy of the set. Discard, remove the specified item. Pop removes an element from the set. The remove removes the specified element. Dictionaries. Dictionaries are used to store data values in key or value pairs. A dictionary is a collection which is ordered, changeable, and do not allow duplicate. Python has a set of built-in methods that you can use on dictionary. Clear, copy, from key, get, items, keys, pop, pop item, set default, update values. If you put dict1 equal to brand, Ford, model, Mustang, year 1964, when you print this dict1, you can receive exactly the same item which you have in dict1. The clear removes all the elements from the dictionary. Copy, return a copy of the dictionary. From keys, return a dictionary with a specific keys and value. Get returns the value of a specified key. Item returns a list containing a tuple for each key value pair. Value return a list of all the values in the dictionary. Let's have a look to Python operation. Operations are used to perform operation on variables and value. Arithmetic operation or operators. We have the arithmetic operators like addition, example is x plus y, subtraction, multiplication, division, modulus, exponentiation, floor division. Assignment operators is like equal, plus, equal. This is example, this is same as. You can see all the assignment operator. We have comparison operator like equal, non-equal, greater than, less than, greater than or equal to, less than or equal to. Logical operation, and this operation returns true if both statements are true, or returns true if one of the statements is true. Not reverse the result, returns false if the result is true. Identity operation or operators is return true if both variables of the same object, x is y, is not return true if both variables are not the same object. Membership operators. We have in, not in. Operator in returns true if a sequence with a specified value is present in the object. Bitwise operators, and, for example, set each bit to 1 if both bits are 1, or set each bit to 1 if one of two bits is 1. Not invert all the bits. 0 fill left shift, this one. Sign right shift. Sign left shift, shift right by pushing copies of the leftmost bit in from the left and let the rightmost bit fall off. Control structures. If else. If you look at this cell, the first control structures in Python is if else. If b greater than a, print this. Else if a equal to b, print this one, else. Another example is here. If a equal to 100, b equal to 50, c equal to 200. The if else do like this. If a greater than b and c greater than a, print both conditions are true. This if structure will control the whole procedure. Another control structure, while loops. Example. For example, we can say continue to the next iteration if I equal or is 3. See here? First we put variable I equal to 0, while I less than 6, I plus 1 equal to 1. If I equal to 3, continue, print I. Means that continue to the next iteration if I equal to or is 3. For loop. In order to use for loop, the example said exit the loop when x is blue. Here I mentioned. But this time the break comes before the print. When they read the item from the variable color, they reach to red, then they reach to blue, because now x equal to blue, break, and print X, the previous one, red. So now it's time to check Python modules. Python modules. What is a module? Consider a module to be same as a code library, a file containing a set of functions you want to include in your application. In Python, you can use dir and help to see the inside a module. For example, here we can say import numpy dir numpy, and they show you all the details as below. Now it's time to discuss about numpy tutorial. Numpy is a Python library for working with array. NumPy is short for numerical Python. It means that the short name. NumPy arrays are stored at one continuous place in memory, unlike lists. So processes can access and manipulate them very efficiently. For installing NumPy, before you do some numerical work, you have to install NumPy. In order to install, you should use this command, pipe install command or NumPy in PowerShell or Anaconda prompt. After installation, you can import NumPy in Python by using this command. Very simple, import NumPy as MP. You can see here at the beginning of coding, you can use this line. Now the NumPy package can be referred to as MP instead of NumPy. So it's time to create one array. NumPy creating arrays. In order to do one array, use the NumPy package. For example, here in this example, we create an array. In this example, we create an array A that is 0D arrays. B is 1D array. And C is 2D array. 3 or D is another dimension array. So when you print A and dimension, they can show you 0 dimension array. When you print B, 1 dimension, D, C, 2 dimension, and D, 3 dimension array. Here I just printed. We print a number of dimension of A, B, C, D using ndim or n dimension. NumPy array provides the ndim attributes that returns an integer that tells us how many dimensions the array has. Array indexing. Array indexing is the same as accessing an array element. Exactly. For example, you want to access to elements in array. You have to write import numpy as MP. You introduce your array arr equal to np.array 1, 2, 3, 4. So if you want to reach or access to elements index 0, you can put print ARR bracket 0. The print show you number 1. So number 1 is index 0. ARR1, they can show you 2. If you want to do some summation, you can put to array index 2 plus array index 3. Index 2 is this one, 3, and index 3 is 4. 3 plus 4 equal to 7. Very simple. We can access to array. Another example. In this example, get the first and second element from the array. Also, get third and fourth elements from the following array and add them. Let's have a look to array. This is two-dimension array. We want to access to the two-dimension array. First start with 1, 2, 3, 4, 5. Second dimension is this one. This is the two-dimension. Second elements on the first row. You can just write it down for yourself. If you want to do that, you can set array 0, 1. Means that the second element on the first row. What is it? Here is 2. Second element on the first row. 5 elements on the second row. What is the 5 elements in second row? You put 10 here. The 5 elements 0, 1, 2, 3, 4. 5 elements in the second row. This is the second row. The fifth element is 0, 1, 2, 3, 4, 5 here. And they will return 10. If you want to access to three-dimension array, you can easily, for example, do this one 0, 1, 2. If you print 0, 1, 2, they will send you to this element 6, and you can easily print it here. In order to negative indexing, if you have this dimension and this dimension, and if you want to use negative indexing, means that this is array bracket and -1, 1 and -1. This is the last element from second dimension. Last element from second dimension. They will return to you. For example, this is when you put 1, it means that second dimension. Okay, second row or second dimension. When you put -1, they will catch from here. Negative index. You can play with different position to see what you have. They will put you 10. A slicing array. Example for slice elements. Slicing in Python means taking elements from one given index to another given index. We pass a slice instead of index like this. For example, array, NP array, 1, 2, 3, 4, 5, 6, 7. You can make it a slicing. 1 to 5 means that a slice element from index 1 to index 5 from the following array. And next is 4, and the right side is empty. A slice element from index 4 to the end of array. A slice elements. Next is when you put left side empty, a slice element from the beginning to the index 4 not included. And if you put -3 and -1, means that a slice from the index 3, from the end to the index 1 from the end. It look like this. We have to check the detail. Let's go back to check array 1 to 5. They slice from 2, 3, 4, 5. See? 4 and the right side is empty. They just take this side. When you put that side, means that they will take 1, 2, 3 and include 4 also. When you put -3, -4, -1, it means that a slice from the index 3, here is index, for example, 0, 1, 2, 3, and from the end to index 1 from the end. This one may be a little bit difficult, but you have to understand from where they slide it here. 5 and 6 they catch. And if you put array 1, 5, 2, return every other element from index 1 to 5. Every other element from 1 to 5. From index 1 to 5. You see here, they just catch these two. Means that 2 and 4. 2 and 4. And when you put two side empty and 2, return every other element from the entire array. Means that 1, 3, 5, and 7. Here is another example. Now I'm going to discuss about array shape. The shape of an array is the number of elements in each dimension. For example, if you have array equal to and by array 1, 2, 3, 4, another side is 5, 6, 7, 8. When you print array shape, they tell you 2 and 4. Means that is the number of element in each dimension. For example, we have 2 dimension, number of element is 4. If you have NP array 1, 2, 3, 4 and n dimension equal to 5. When you print array, they will show you like this. 1, 2, 3, 4, but it seems 5 bracket left and 5 bracket close and open right. If you put print shape of array, array.shape, they mention to you 1, 1, 1, 1, 4. Means that from 5 dimension, the last dimension have 4 items, the rest have 1 item. Reshaping. Reshaping means changing the shape of an array. Sometimes you need to change the shape of array. Array equal to NP array 1 to 12. New array equal to array.reshape 4, 3. Print new array. When you print a new array, let's see what happened to the first array. Here is the first array. It seems is the 1 dimension. And when you reshape to 4 and 3, and if you add it to new array, when you print the new array, it means that you can get this one. The first row, second row, third row, and the row 4, and it is reshaped already. So another example is new array 1 and reshape 2, 3, 4. Means that when you print it 2, 3, 4, they will show you like 1, 2, 2, 4, 3, 4, 5, 6, then the rest is 7, 8, 9, 10, and 11, 12. It means that by reshaping, you can reshape the structure of array. Let's have a look to unknown dimension. You are allowed to have one unknown dimension. You should pass 1 as the value, and NumPy will calculate this number for you. For example, you introduce NP array 1 to 8, new array, and reshape 2 to -1. When you print it, you can see this unknown dimension 1, 2, 3, 4, 5, 6, 7, 8. This is the unknown dimension. Another example is to convert the array into one dimension array. How is possible? For example, when you have new array equal to array dot reshape -1, when you print new array from the previous, they will convert the array into one dimension. The previous one is unknown dimension. Then how is possible to convert to one dimension? By reshape -1. Another topic that I'm going to talk is joining array. Joining means putting contents of 2 or more arrays in a single array. In NumPy, we can use concatenate function. Concatenate or concat is the function that you can join 2 arrays together. For example, you have one array 1, 2, 1, another array 2, 4, 5, 6. Then by np.concat array 1 and array 2, you can simply join 2 arrays together. Another example, join two-dimension array along rows, means the axis 1. 2 dimension, if you look at this one, array 1 is 2 dimension, 1, 2, 3, 4. Array 2 is 2 dimension, 5, 6, 7, 8. You have to practice more in order to understand what is 1 dimension array, what is 2 dimension, and n dimension. When you concat array 1 and array 2 with axis equal to 1, this is already joined to the array along with rows 1, 2, 5, 6, and next is 3, 4, 7, 8. So the next step is to understand the splitting option or function in array. Let's suppose we have one array, one dimension is 1, 2, 3, 4, 5, 6. If you are decided to split it, it means that you have to reserve operation of joining. When you join, then you have to split. Split the array in 3 sections. np.array split array and 3. When you print new array, the first one is like this: 1, 2, array 3, 4, array 5, 6. Now if you split the array in 4 section, you see 1, 2, 3, 4, 5, and 6. Why such kind of thing happen? Another example of splitting here. We want to split the two-dimensional array into three 2D array. Let's have a look to the first array. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. Now you want to do array split in 3 sections. When you print, you will receive such kind of thing: 1, 2, and 3, 4 in 2-dimension. 2-dimension array into 3 2-dimension. See here, 1, and another one is this one, and another one is this one. In fact, we reached to 3 2-dimension. The one dimension is this, another dimension is this, and another dimension is this. Means that 3 2-dimension. You have to do more exercise in order to understand the way of splitting and concat. Here we are going to talk about searching array. In searching, you can search an array for a certain value and return the indexes that get the match. For example, we have one array, 1, 2, 3, 4, 5, 4, 4. And by using where array equal to 4, when you put this np.where parenthesis array equal to 4, and if you put to x, when you print it, they bring 3, 5, and 6. The indexes of this array, the position, the location of 4. Location of 4 is, if let's suppose the index started from 0, 0, 1, 2, 3. 1, 4, the index is 3. That is why you can see here 3. Another 4, index 5. Another 4, index 6. And data type also they can show you. Another example is array mod 2 equal to 0. They can convert it and you will see this location for searching array. When you're going to sort an array, you can simply put np.sort. The array will be sorted by ascending, means that from low value to high value. Another example, if you have character or string, red, green, blue, when you put sort, they put blue, green, red, because B is high priority than G than R. Another section is filtering. Filtering array. It means that getting some elements out of an existing array and creating a new array out of them is called filtering. Look at this example. We want to create an array from the element on index 0 and 2. What is index 0? Here 41. What is index 2? 43. When you have an array np.array 41, 42, 43, 44, and if you put one value or variable x and put true, false, when you do one simple filtering, means that new array equal to array x, the x will see or match those elements that their value are true. Here the index 0 and index 2 are true. That is why You can see when you print new array, they will show you 41 and 43. Another example. Here we have to create a filter array that will return only value higher than 42. This is another. You have NP array 41, 42, 43, 44. The question is, we want to use or create one filter to return only value higher than 42. First, create an empty list. Filter array equal to empty list. Then you have to go through each element in array. Array is this one. You have to go through each element in array. For element in array, then you have to do if then else. If the element is higher than 42, set the value to true, otherwise false. We can do this one. If element greater than 42, filter array append true. Otherwise or else filter array append false. Then put them to new array, array filter array. When you print the filter array, you can reach false, false, true, true. The one exactly we catch from here. Because 41 and 42 are less than 42, right? Because I said higher than 42, you can print it. But because 41 and 42 are less than 42, then the two elements are false. Next element is true, true. So the next step, now it's time to print a new array, 43 and 44. Here is. The last example, creating filter directly from array. What does it mean? No need to put if then else on. When you have this array 41 to 44, filter array equal to array greater than 42. When you get this value filter array, just array bracket filter array put to new array. Then you can see that when you print filter array, and they will show you false, false, true, true, and exactly like the previous one, print new array, they will show you 43 and 44. Now I'm going to discuss about plotting or matplotlib. Matplotlib is a low-level graph plotting library in Python. Matplotlib library. For installing, you should run the command like this: pipe install matplotlib if you don't have in your Jupyter notebook. After installing, you can import it in Python environment by using import matplotlib because it is available in the package. Let's have a look to one example. We want to draw a line in a diagram from the position 1, 1 to position 10, 100. The 1, 1 is here, and another position is x 10 and y 100. So in order to do that, you have to import matplotlib.pyplot as plt, and of course you need the numpy. So the position of x or x points you can mention 1, 10. The position of y is 1 or 10, 100. So here you have to draw one figure. The figure size is 12 to 6, the wide and high. After this you have to plot it. Plot plt.plot x points and y points. And after this you can put plt.show then they will show you exactly the position that we have here. See, position 1 1 to position 10 100, 1 1 to position 10 100. They already mentioned whatever we have. Another example, draw 2 points in the diagram, not line, 2 points. One point is here, another point is here. One position at 1 1 and one position as 10 100. In order to do that, x point 1 10 is located here, another one is 1 100, and you can see plt dot figure from the figure size that you have here. This figure, when you put x points and y points, you have to mention by one symbol. This symbol is points, for example. I put O or something. PLT dot show, then they suppose they are sample. The sample already mentioned to these 2 points. So let's have a look to some more example. Let's suppose x points equal to array 1 2 4 5, and y points equal to another array 3 4 1 4. Now when you want to draw it, you have to make one figure by the figure size, then plt.plot x point and y point, then plot it. You see what happened? Exactly, they put these two array like this one. So if you look at to this example again, we put x point and y point. Okay, it means that x-axis, y-axis. If you look at to x-axis, we have 1, index 0 is 1, and y-axis index 0 is 3. Means that if you look at this figure, x is 1 and y is 3 here. Another one is 2 4, 2 and 4. The rest also same. Here we have only y points. If you have y points, you don't need to worry about x points. Y points, they just located or allocated by 2 8 3 10, and I put one marker like O. And when you look at the y point, the first one is 2. Only look at to y axis 2. Another one is 8. See, 8. Another one is 3. See here. And another one is 10. This is the y points that I already mentioned to this system. So another example, when you want to plot figure size, you can do the previous y points and with a star. The marker this time is a star. See, instead of O or circle, you can put a star. Or another interesting point is OR. Means that red color and with a symbol circle or O. Exactly for y points. Or you put green, only put G. You can look at this one and you will find how the green happen. And also you can resize the marker. For example, marker size 15. It means that they make it bold. The marker name is O or circle. And if you put dot, line style dot here, it's interesting now. If you put dash, like here, it means that you have to mention line style equal to dashed here. If you put color red, is like this red line. And if you put line width is 20. It's too big. And another one is you want to make your figure interesting. You have to put add title and label. In order to do that, you have to first draw the figure. Figure size is 12 to 6, and you have to plot the points. Here we points, y points, for example. Now it's time to put title and label. plt.title, title. plt x label, axis x, for example. plt y label, axis y. Then plt show. Here you can see that x-axis we put axis x, y-axis we put axis y. This one also is title. Now it's time to make something more interesting. So define the font for title and axis label. After you make it something interesting, you have to do some work with the font. So font 1, font 2. Font 1 is family, for example serif, and color blue, size 20. Font 2, for example, I put family, for example serif, color is dark red, and size is 15. Here you can see that, okay, for title, font dict equal to font 1. They will refer to this one. And for the title, they can put blue by size 20. How about axis X? X label. You can put font 2. What is font 2? Dark red. You see? Yeah, dark red, size 15. For y-axis, I put font 2 again, dark red and size 15. This is very interesting one. If you want to put grid in the figure, only at the end of label, for example, you can put plt.grid, parenthesis, grid on. They can put the grid with cell inside. And another interesting part is subplot. In order to make a subplot in Python, you have to draw, for example, two plot 1, which is x and y, and after you draw it, you can put figure, plt figure, you can mention a figure size. Then here is time to put subplot, plt.subplot 1 to 1, and plt.plot xy. So let's have a look to x and y, what will be happen to this one. So as I mentioned to you, the subplot function takes 3 arguments that describe the layout of the figure. The layout is organized in row and columns, which are represented by the first and second argument. The third argument represents the index of the current plots. For example, here plt.subplot 1, 2, 3. This is the first, second, and third argument. If you look at this one, for example, plt.subplot 1 to 1, the figure has 1 row, 2 column, and this plot is the first plot. That is why here you have to mention this plot is the second plot, for example. It's very easy to follow up. This is another example of subplot, but they put the title. For example, plot 1 and plot 2. Exactly same like previous one. So how about the scatter plot? Scatter plot. With Python, you can use the scatter function to draw a scatter plot. The scatter function plots one dot for each observation. Here like this. In our machine learning course, we need it. It needs 2 arrays of the same length, one for the value of the x-axis and one for the value of y-axis. If you look at to this example for a scatter plot, we have the x point and we have the y point. After we make the color, So the color is the type of array that we have different type of color from 0 to 100, and it's time to plot the scatter x and y. C equal to color and C map. Read this, and when we plot the color bar, they can show you such kind of thing. And now it's time to plot show. When you plot show, this exactly the location of each x and y will be allocated for with each color. Now bar chart is another interesting plot in Python. With pyplot, you can use the bar function to draw bar graph. You see here, you have A, B, C, D, array 2, 8, 1, 12, and figure size, and you can put the bar, x, y, and plot show. You see the x is A and y is 2. You can put different values in x and y and use the bar chart for it. Histogram, in matplot, we use this hist function to create histogram. For example, here is a normal data distribution but numpy, random.normal, and when you put 180, 10, 200, they just randomly create something for you. This is the x, for example, x value, and now it's time to plot it. So if you want to plot, again, you can put the figure size, and this random value will be plotted based on the histogram. So histogram, for simplicity, we use numpy to randomly generate an array with 200 values, where the values will concentrate around 180 and the standard deviation is 10. This is the histogram that we mentioned. The histogram code also are here. The last chart is pie chart. With pie plot, you can see pie plot. You can use the pie function to draw pie chart. In this code, we show a simple pie chart with table or labels. So here is y and my label A, B, C, D. For example, 30%, 40%, 10, and 20. Then after you draw a figure, the size almost same. When you put plt.py, y and labels equal to my labels. Here is it my labels, which is A, B, C, D. They put to the label. Then when you plot show, they will show you such kind of thing. So another example, explode and legend. If you want to explode, for example, A and put the legend for it, you can here put explode, my explode, but it depends from where you want to put the explode. For example, this person. And now you have to put one legend for it, and lastly you can plot based on the show. So in this example, we have to pull the A wedge 0.2 from the center of the pie. See, from the center of the pie, and show the legend for the pie chart. This is the example that we want to finalize the system.